Hey everyone, so today we're going to be going through Data Challenge 4. So the goal of this data challenge is to look at a list of, or a data frame of almost 100,000 beers that are from all over the world. And there's information contained in here about not only how many times it was reviewed, but also that average score, who the brewery was, what state or country it was made in, and even when it was added. So you've seen beers being added as craft beer has taken off over time. Over the last decade or so. These are all taken from the website ratebeer.com, or I'm sorry, beeradvocate.com. And so the goal is to slim down the data frame into sort of only looking at relevant American beers, check for some outliers, and do some filtering. So in this way, we only have the data set that we're looking for. And then to get some ideas about how alcohol content, for example, interacts with rating across different styles of beers. So as always, we're going to load our library, and then we'll also bring our beer data in. So it's kind of a bigger data frame, so it's going to take a second to load and just grab from Google. And you can see here that there's a number of different columns embedded in here. So for example, first we have the number of reviews, which as one would expect, it's the number of times the beer has been reviewed. And so this can range from only a couple times to thousands of times if the beer has been really popular. Brewery name, city, and country, these are all kind of self-explanatory, same with beer name. Beer overall score. So this is the average across all those different reviews. So if a beer has been reviewed 6,000 times, it's going to be the average of all those different reviews. Style, there can be actually a lot of different styles present. And so these styles, as we'll see, is kind of too many for us to look at. So we're going to actually tone it down a little bit and only look at a few. ABV, so this is a critical one, alcohol content by volume, so the percent alcohol. We can see this is also being brought in as a numeric, so it looks like it's probably clean. Add date, and then that's the date that it was added to beeradvocate.com, and then finally the year, so that we might have some redundant columns there. So again, let's just take a sec to explore using all the different methods. We'll try a glimpse. Beer, we'll run that. And so again, here we can see number of reviews. So a high number of reviews for some of these, a lot of them actually here. That's at the top of the data frame. Scores, so this kind of ranges here from 0 to 5, but really the minimum should actually be 1. You can't actually give a beer lower than a 1 on Beer Advocate. We can also just do a summary to kind of see the range of those values. So for example, number of reviews, so the minimum is 0. So that actually should kind of cause concern. We probably don't actually want those beers in here if we're interested in sort of preferences, right, of how people actually have rated them. If they didn't rate them, we don't want them. Brewery name, country, all those, we'll have to look at some uniques. And then finally, alcohol content. So the minimum is 0.5%, so 0.5% alcohol. And then the highest here is 32. So there's some really heavy beers. And then years we see range from 96 to 2018. So a lot of information in here. So we're going to probably want to do some things to kind of slim this down a little bit more. For example, we only want to look at beers that are actually in the US. So if you look at this and do unique beer, and then we look at the country, what we see here is that we have both the United States, a bunch of NAs for country, United Kingdom, and Canada. And so part of this is that the country was actually kind of difficult to scrape. So I was only able to get countries for certain countries, and a lot of other ones I wasn't able to get the countries. And again, we're also only interested in the United States. So for the purpose of this data challenge, we're going to look there. So we're going to use our typical tidyverse type syntax here and use the filter function. So we're going to take our data frame beer, then we're going to apply a filter. We're going to do to a specific column, in this case, brewery country. And then we're going to filter by United States. And since this is a character string, we want to make sure that our text is exactly what it is over here, right? So case matters, spaces matter, so on and so forth. Otherwise, it's not going to match exactly, and therefore you'll just get back nothing, or the whole data frame in this case. So go ahead and run that, and then we're also going to omit all the NAs. And so then we can go here and we can take a look and see, well, how many rows are there? So in the original one, sorry, I can't type today, we have a grand total of 82,000 beers. And in beer 2, we have 51,000. So we can actually kind of see, well, how many beers did we lose in the process of this? So of slimming it down to just the US. Beer. And then we'll subtract off beer 2. And so we have 30,750 beers. So those are all the beers that were originally in the data set from different countries we're not going to look at. It's still a pretty amazing number of beers when you think about it. There's 51,000 different beers being brewed in the US. A lot of that because of the whole craft beer explosion. So there's also a lot of styles. So I just put this code in here for you just to remind you. And so you can see there's some of these are pretty unique. And if you aren't like a big beer nerd, you probably have never even heard of these things or have no clue what they are. Alternatively, though, there's a lot of styles that, a lot of people might have heard of, stouts, for example, IPA, even a pale lager or something like that. So we're going to focus on some of these more common ones. And so what I did here is I have a list of 5 of these really common beers. Adjunct lagers, which are these really light beers like a Bud Light or a Miller Lite that are made normally by American breweries. IPAs, double imperial IPAs, stouts, and double stouts. And so this is basically IPAs are a very hoppy beer, and then these ones are stronger versions. Stouts are very dark beers, and then these are stronger versions of stouts. And so what we want to do is we want to take our list of American beers right here, and so we'll run it. So now we have that. We can check it out again. And so there's our list of 5 different beer types, and we want to then filter based on that. And so we're going to use this similar syntax right here and apply it here. One thing that we're going to do, though, is we're going to assign this to beer 3. And we're doing this, which is kind of sometimes useful early on in the process, to not continuously be overwriting your data frames in case you make a mistake. So for example, let's say you decided you wanted to add in, say, a pale wheat ale to this list. You could go and amend it, and you wouldn't have to go back and re-import your data from the beginning. You could just amend it here, and you'd only have to go back to beer 2, for example. So it's kind of a useful thing to do. I normally still go back, and then after I have my code working how I want it to, then I'll make it to where it overwrites data frames and replaces them. But for now, beer 2, we're going to reassign it as beer 3. We're going to filter it. Sorry, I can't type this morning. And then we're going to take brewery country, or I'm sorry, style. And then everything we're going to select all styles that are found in this, right? So where their character strings match something in this list. American, and so we're going to run that. And now let's check our styles again, and how many do we have? 5. Okay, cool. So this worked exactly how we wanted it to. So it went here and grabbed just the styles that are in that. Let's just look how many beers are now in our data frame. So we'll check beer 3 and run that. And so we see only 9,200. So that means that almost 20,000 of the beers that we got rid of are all being made in America, are all these other different styles. So we actually threw away a lot of data. But that's okay if you're, in this case, we're just kind of concerned with a few of these really common styles. You could easily go and expand this later or do a similar analysis, but on a different subset of beers. So for now, let's go ahead and let's go ahead and do a little more cleaning. So for example, here, what I'm asking for is to clean up a little bit of the naming. So if we just look at the head, or even we can just do names, beer 3. What we see is that some of these things the column names are pretty nice. Brewery name, brewery city, country, for example, those are fine. But there's certain things we could probably change. For example, beer overall score, we could probably just change that to rating. And then actually, if we look at the head here, there's something else that I remember. So what we see with the head is that we have brewery city seems to be overlapping with, or seems to be the column of actually brewery states. So given we want our proper column names, we should rename that. And so the format that you use to rename it is use a select function, and you use this new name, old name format. So what we're going to do is now we'll assign this to beer 4 again, so we don't rename beer 3 in case we make a mistake. We'll take beer 3, pipe for then, select, and then remember new name. So for example, rating is what we want our new name to be, is equal to, and then in this case, beer, we don't need this in quotes, beer overall score. And then we also want now to rename brewery city as brewery state. state is equal to brewery city. Okay, great. So let's run that again. We can just check our head beer 4 now. Run that. And what do we see? That I made some mistake. So this is exactly one of the reasons why it's nice to not overwrite your data frames. Oh, here's why. Because it's really early morning. I'm using select, so I'm just selecting out a couple columns and renaming them in the process. Instead, let's use rename function as we should be doing. Now let's look. Okay, duh. Also learned something interesting is that you can apparently rename while also doing a select. So we're going to actually do that next. But for now, it looks like our renamed worked. We've renamed brewery city to brewery state, and then now we just have rating, which is just going to be easier to work with and easier to type. Okay, now we're going to do our select. So we don't need all this information. So if you look here at our data frame, the number of reviews we probably want to keep, brewery name we want to keep, and state we want to keep. But brewery country is like super redundant. We already selected out the United States. We don't need a column telling us again that it's in the United States. Along those same lines, we have some similar information here contained within year and add date. So if we do a glimpse beer 4, what do we see? We see that the year is part of the add date. And so in this case, we're kind of only interested in that rough year-wise scale. We don't need the specific date that it was added. So we can go ahead and actually remove add date too. So for select, we're going to do this kind of the longer way, which is just choosing the columns you want to keep. There are ways to do it to where you tell it to get rid of columns, but we're going to stick with what I showed you in class. So number of reviews. We want brewery name, brewery state, and then we want beer name for now, rating, style, ABV, and then year. And so now we can go ahead and run this. And let's go then, just as always, just to verify that we have just the number of columns we want. So head beer 5. And what do we see? Cool. So it brought it down to just a little slimmer data frame, a little easier to work with, got rid of some redundancy. And so this way we're just working with less data and only the relevant data. And so now we have this kind of cleaner, more concise data frame. And so now we can actually start looking at some trends and start making some plots to look at how, in this case, we want to look at how alcohol content influences rating. So we're going to make a ggplot or a plot using ggplot. So as always, call beer 5, comma, and then you have your aesthetic. So we want to see how ABV influences rating. And so that means we want ABV here on the X, and then rating in response to it. And so our responses we always want on the Y. So rating, and we can go ahead and run that. And so this will take a second. We can make this a little bigger here for now. And so we see, obviously a high density of points, but the other thing we see is that there's actually this bundle down here at 0, and these are these 0 rating individuals. And so what this is saying is, remember, there's some ones that can have a rating of 0, but only because they were never reviewed. And so that isn't really relevant. That's obviously like not important information for us because we're interested in actual reviews, not just sort of automatically getting a score of 0 just because no one's reviewed it. And so we want to use now another filter. And so this kind of highlights that process of visualizing things, realizing there's maybe some error or something you want to adjust, and filter accordingly. So this one, I feel like we're good enough with filtering that we can take beer 5 and just reassign it right back to beer 5. So filter, and then we want rating. And we only want to take ratings that are greater than, in this case, 0. And this, in theory, should just get rid of those bottom 0 rated individuals. And so let's do that. And we'll just come up here and just do a quick plot. Cool. So if you can see now, here's the plot that we just made. All those ones are gone. So this is one where actually it might be 0.1 as its rating, meaning a bunch of people reviewed it and hate that beer. And then this is an old plot where you can see there's a bunch of these zeros. I'm sorry, this isn't actually 0 anymore. This is like 1.5. So still a very poorly rated beer, but since zeros are gone, you can see that our axis range has changed. Okay, so we have that. And now I'm also saying let's go ahead and add a little bit of a trend line here just for some more clarity and so we can start visualizing this trend. And so here what we do is I'm going to be bad here and copy and paste this. And we're just going to add on a trend line. Remember that you can add on trend lines and various types of trend lines with this function geom smooth. So you can layer on different geoms. So in this case, geom smooth. And then our method in this case is LM, which we'll learn more about later. But under the hood, what it's doing is it's fitting a regression line of this relationship. So let's run it, give it a second to calculate. Okay, and we see like a nice positive relationship there between alcohol content and rating. So generally speaking, people like more alcoholic beers, but we don't know why this could be. Maybe ones with more alcohol are just actually higher quality, so there's better ingredients and that sort of stuff. And so that's what drives a higher rating, not that people necessarily just like more alcohol. I'm sure it's some interaction of both. People like both alcohol and good beer. Okay, so we're going to do a couple other little plots here to kind of explore this relationship a little bit more. So that was a relationship, like a scatter plot of these two continuous sets of data points. Now what we want to do is let's go and look at how styles differ and then the ratings differ in response. And so we're going to make another ggplot and still using beer 5. And then since the blocks plot, we want our groups on the x-axis. And so our aesthetic is going to be x is equal to style. And so this way it'll make a box for each of the 5 styles. And then y, we want to look at our ratings. Okay. And then in this case, we want geom box plot. And so we can start and just run this. And so we definitely see something, and I'm working on a really big monitor, so these texts appear just fine. But if you're on a smaller screen, you're actually going to see a lot of overlap, and we're going to fix that in a second. But for now, what you can see is that, okay, American adjunct lagers are very low, and then we can see, and there's a lot of variation given the size of the box around the mean line here, compared to some of these other beers, right? Double Imperial Stouts, these are very high alcohol beers, also have very high ratings. Same with Double Imperial IPAs. Those are very high alcohol beers, also have high ratings, kind of what we saw in the last plot, but seeing how the styles themselves differ. Anyway, so one downside to a plot like this, when you have really long titles on for each of the styles in this case, is that if the figure is kind of small, you start getting a lot of this overlap here in text. Which is obviously not very helpful if you want to actually see. And so you can add just something called a coordinate flip, and you'll see what it's going to do here is it's just going to flip our x and y axes. So chord flip right here. And so this is really nice because then what it does is it allows longer text labels to be displayed in sort of a more readable way. And so it's, again, just sort of an idea of one of these aesthetic things that makes it easier to look at the plot that you're working with. Okay, cool. So we've learned a little bit about our beer ratings. We've learned that the high alcohol beers is actually falling into these 2 categories, and that these ones have higher ratings compared to these American Stouts or IPAs, which are still rated very highly on average. And then adjunct lagers, Miller Lights, Bud Light, these really light, cheaply produced beers overall have much, much lower ratings, and some of the ratings go down to very, very low. So a lot of people don't like these beers. That's not necessarily surprising, though. This is on a beer review website. This is a bunch of beer nerds reviewing beer. So, of course, they're not going to really like those cheap beers. Okay. So we can now answer this question. According to a figure, which beer style has the lowest? That's those adjunct lagers. Highest is then the big Double Imperial Stouts. Okay, so now we want to actually look at how things have changed over time. We have our year axis, and here I'm talking a little bit about how craft beer has exploded in popularity over time. And so let's go and look at the relationship between ABV and year. So in this case, we want to, again, ggplot, beer 5. And then for our aesthetic, what we want is X is what we're looking to see how it varies across. So in this case, year, so how it changes over time. And in response to time, we want to see on our Y then, ABV. And so we're going to go geom point. And then we're also going to just add our fit line right off the bat, just so we can then visualize this relationship a little bit easier. Geom smooth method equals LM. And so we can run that. Okay, so we see a positive relationship. So as kind of craft beers exploded, we've seen higher and higher alcohol concentrations to where the average in this database is actually, almost 7.5%, which is quite powerful from the quite a bit more compared to the 5% that it was, back in a little bit before 2000. We can do a couple more things though. So one downside when you're working with these groupings of years, for example, is that all of our data points stack up like this. And so it's actually really hard to visualize how many beers there are. It just kind of turns into this black line. And so what we can do is, remember, instead of points, we can do geom jitter, which then adds some noise around these points. And so here now this adds a good bit of spread. And so you can see that not only has the number of, or the alcohol content increased, the number of beers being produced each year and added each year has really, really taken off. This is 2018, and I took these data mid-year, and so it's obviously not very filled out yet. But 2017, you can see this nice steady growth in the number of beers produced each year. Okay. So why do I make the following changes? I should read my own directions. So instead of use geom point, use geom jitter. I just did that. And let's actually, this is a good point. Let's add this alpha equals 0.1. And so that's going to add some transparency to the points. So then this way you can visualize them easier. We're also going to change the theme to classic so we can get rid of that background, that gray background, classic. And then also we're going to increase our label sizes. Is the other thing that I ask. So theme and text. This is, again, one of those things where it's going to take you a while to learn and remember these things. So make sure you look back on your notes. Element text. And then size 20 tends to look pretty good. And so that looks pretty good. And then I also wanted to color my points by the style of beer. And so here what we can do is go ahead and color equals style. And let's go ahead and run that. And it'll take a second. Cool. Okay, so what do we see? So in response to my very last question here, based off this figure, have all the beer styles increased in alcohol over time? And so we have our fit lines for our 5 different types of beer. And what we can see is that even though alcohol content has increased over all beers over time, it's actually not every single style, right? So if you only group everyone and look, you get this impression that it's all beers that are increasing. And that's actually not true. What we see is that there's a very positive increase here in this style of double American or double imperial stouts. And similarly, American stouts have increased in alcohol. The adjunct lagers, the orangish line right here, is super flat, as is American IPAs. These have always been a little under 7%, and they're still a little under 7%. And these double imperial IPAs seem to have shown actually a trend to maybe decrease a little bit in alcohol content. And so again, this really highlights the point of the importance of looking at individual groups and trends and patterns over time, rather than necessarily lumping them all together, because you could have different patterns as a whole compared to when you look at individual groups. And so that's it for this data challenge. Of course, please let me know what you thought of this video, and feel free to email me with any questions.